Welcome to the Mountain Path, the world of finance. This is Ravichandran. In today's session, we will discuss Black-Scholes option pricing model and how to price call option put options when yield of an index is given in percentage. In the previous videos, we discussed how to calculate call option put option using a dollar dividend that is given within the period life of the option. So the pre-requirement for this session is a basic understanding of the options called and the payoff, option moneyness, and the option pricing determinants and put call parity. In subsequent sessions, we will discuss about implied volatility, how to calculate implied volatility using Black-Scholes option pricing model. We'll also calculate how to calculate call option put option price and for currency options as well as commodity options, and we'll also calculate how to calculate arbitrage when there is a and option pricing and differences between the model price and the market price. So last video we discussed how to calculate call option put option when the dividend is given in dollars, when the dividend is paid within the life of the option. So one of the important steps that we discussed was to calculate the present value of dividend, subtract it from the current stock price. So we calculate the adjusted stock price, then we use it in the Black-Scholes option pricing model, then we calculate D1, D2 and norms inverse of D1, D1, D2, and then we calculate call option put options. Now we are going to discuss today how to calculate and the call option put option pricing using Black-Scholes option pricing model, and when the yield of an index is given in terms of a percentage. Let's assume the inputs of the model, the current index price is 100 and the volatility is 25%, the risk-free rate of interest is 8% and the time to expiration is 6 months and the strike price is given as 110. Let's assume the 3% yield, annualized yield is given, and let's assume this yield is and happens within the life of the option. So let's calculate the parameters of the option, Black-Scholes option pricing model. And first we calculate the numerator of the D1, that is the ln of S divided by K, and then R minus Q. Here comes the modification when you calculate the D1 actually. So you have to calculate R minus Q. That means instead of a risk-free rate of interest plus half the variance and into time divided by square root of and time into sigma. So we have to subtract the yield from the risk-free rate of interest. So this is one important change that we need to do here when you calculate D1. So once you calculate D1 and D2, then normal distribution of D1, then normal distribution of D2, then present value of K. There are no changes here. So one changes what they do is subtract the annualized yield from the risk-free rate in the D1 calculation. Then calculate call option price. Again we need to do a small adjustment here. When it's current stock price or current index price into exponential minus Q into T. That is the stock price is actually discounted with the yield. So S0 into exponential minus Q into T into N of D1 minus present value of K into N of D2. So these two areas we need to do adjustment. Again when you are calculating put option price, and we have to calculate and K present value of K into N of minus D2 minus S0 into exponential minus Q2 into N of minus D1. You can also check our calculation using our put call parity equation. Again when you are checking put call parity equation, and so call plus present value of K is equal to put plus stock price into exponential minus Q into T. So you should know the adjustment that we need to do whenever yield is given during the life of the option. This is like a modification of a Black-Scholes option pricing model. So one more quick example we'll take. Consider a European call option on an S&P 500 that is 2 months from maturity. The current value is given as 930. The strike price is given as 900. And the risk-free rate of interest is 20% on continuous compounding basis and 8% risk-free interest on a continuous compounding. The time is 2 divided by 12 and the yield is given as a 3%. Now calculate the D1 using the parameters, using the model inputs. That means again we need to calculate ln of S divided by K plus R minus Q into variance and into time divided by sigma into square root of time. So once you calculate D1 and D2, then calculate normal distribution of D1, normal distribution of D2, then calculate n of minus D1, n of minus D2, then we can calculate call option. Again we should not forget spot price into exponential minus Q into D into n of D1 minus present value of K into n of D2. So whenever the yield is given, don't forget to do adjustment in D1 as well as call price as well as the put price. So we can again check the put call parity, it will be absolutely true. So thank you for listening. So the next video session, and we will look into binomial, that is a Black-Scholes option pricing model, and how to calculate currency option, call option using currency. Then we'll also look into commodity pricing also, and we'll subsequently go into implied volatility and other areas related to Black-Scholes option pricing model. Thank you very much.